So the speed of a sound in a medium depends on the wavelength. It depends on the Young's modulus E. It depends on the density. Use the method of the base unit, derive a formula for the speed of a sound in a medium. So speed of a sound depends on the wavelength. So we said speed of a sound is directly proportional to wavelength raised to power x. It also depends on the Young's modulus. So we say speed of a sound is directly proportional to the Young's modulus raised to power y. And speed of a sound depends on the density as well. So we said speed of a sound is directly proportional to the density raised to power z. Now, if we combine all these factors like x, y, and z, so what will happen? This will be, we can say that speed of a sound is proportional to all of these factors. So I can say that speed of a sound is proportional to lambda raised to power x, the Young's modulus raised to power y, and the density raised to power z. Mathematically, when we represent the equation, when we replace the proportionality sign, we replace with equal to and the constant. So in this case, we'll replace with equal to and we put a constant k here. And we assume that this k is a dimensionless quantity, like it does not have any dimension. Dimensionless quantity, when I say like it does not have any unit, that's our assumption right now. It maybe it has a unit, but when we derive a relation, we assume it does not have any unit. So now we just substitute the values, like the units. The unit of the speed is meter per second, so we can say ms minus 1. K, we assume it's a dimensionless quantity, so it does not have any unit. Lambda is a wavelength, the unit of the wavelength is meter, and that is raised to power x. The unit of the Young's modulus is given, that is kilogram, meter raised to power -1, second raised to power -2, and whole is y. And the density, which is kilogram per meter cube, so kg, meter raised to a -3 raised to power z. Then we simplify this m raised to power x, this kg raised to power y, m raised to power y, -y, and second raised to power -2, 2y. Then kg square meter raised to power -6. Now this is ms minus 1. So this is m raised to power x, m raised to power y, and m raised to power z. Sorry, I wrote 6. No, it's 3z. Sorry, because it's 2 multiplied by z multiplied by 3, not the 2. So this will become 3z. So it will be m raised to power x minus y minus 3z. That is the value for m. Then kg, this is kg, this is also kg. So the kg raised to power y plus z. And the second raised to power -2y. Now we'll compare their exponent. In this equation, kg does not have any unit here, like the kg does not, it's given. So the kg on the left hand side is 0. So we compare the power of their units, like kg is 0 here and kg is y plus z. So we can say 0 is equals to y plus z. That is equation 1. 0 is equals to y plus z, equation 1. Here meter is 1 and here meter is x minus y minus 3z. So we can say 1 is equals to x minus y minus 3z. And the last one, second is -1, and here second is -2. So -1 is equals to -2y. So we have 3 equations. We'll solve like if I take this equation first, I can directly get the value for the y. If -1, I will solve here. If -1 is equals to -2y, negative will cancel with negative. So 1 by 2 is equals to y. So I got the value of half. Then if you see this equation, in which 0 is equals to y plus z, I can substitute I can substitute the value of the y to be half. It move other side, so it will become negative half. So value of the z is negative half. Now how to get the value of x? If I want to find the value of x, we can use this equation in which 1 is equals to x minus y minus 3z. If I need x, I move all other side. So 1 plus y plus 3z is equals to x. And I'll substitute the values. So this will be 1. The value of the y is half, 1 by 2. The value of a z is negative 1 by 2. So I will substitute minus 1 by 2 is equals to x. When we simplify here, we have 1 plus half minus 3 by 2 is equals to x. 2 will be the LCM. So when we simplify, this will be 2 plus 1 minus 3 is equals to x. Or 3 minus 3 divided by 2 is x, or x is equals to 0. So we have the value of x, y and z. So value of x is 0. So means this factor, because this was the original equation. The original equation is v equals to k times lambda raised to power x, e raised to power y, and density raised to power z. So lambda, the power of x is what? The power of x is 0. So lambda is 0. What about, so anything raised to power 0 is 1. So lambda will not be included in the equation. E raised to power y, which is half. So this is half. And density raised to power z, which is negative half. So when we simplify, this will go there in denominator. K e raised to power half, which is means under root e. And lambda will go there in division. So it will become minus 1 by 2. Or it will be lambda rho. Oh, sorry, not lambda rho, I mean. Lambda is this one. So this is an equation which relate the Young's modulus, density and K. This was an example I did in the last session as well. Another example, in this question, the example 1.5, velocity of a seawater depends on the wavelength, the surface tension and the density. Deduce the equation to show a relation between these quantities, and in the experiment the following values of a velocities and the wavelengths are obtained. The value of the surface tension and the density of a seawater are given, but we have to first establish a relation. So velocity of a seawater is proportional to wavelength raised to power x. It is proportional to the surface tension gamma raised to power y, and it is proportional to the density raised to power z. So when we combine these, so v will be equals to k times lambda raised to power x, gamma raised to power y, and rho raised to power z. Now we substitute the unit. The unit of the speed is meter per second. So this will be ms minus 1. K is a dimensionless your constant, does not have a unit. So lambda is meter. So x. Then gamma, the unit of the gamma is given Newton, meter inverse, because it's Newton meter inverse, and raised to power x, raised to power y, and gamma, it's kilogram per meter cube raised to power z. But the problem here, the Newton is not the base unit, so we have to express the Newton in base unit. So we will change this. So this will become m raised to power, no, it's a surface tension, which the representation is by using a gamma. It's not the gamma radiation, it's just the surface tension, which is represented by a Greek alphabet. Like gamma. So it's a surface tension, which unit is Newton per meter. Now Newton itself, it's not the SI unit. Newton is not the SI unit, so we Newton itself is kilogram meter second raised to power minus 2.
That is what Newton. And meter minus 1 multiplied by y. And then this will be simplified, kilogram raised to power z, meter raised to power minus 3z. Now we simplify this further. So ms minus 1 is equals to m raised to power x, kilogram raised to power y, meter raised to power y, second raised to power minus 2y, meter raised to power minus y, and kilogram raised to power z, meter raised to power minus 3z. Further we simplify in terms of, so here I'm writing ms minus 1 is there. The final for m, it has x here, unit x, and here it has y, and here it is minus y. Because the unit of force is Newton, and Newton itself is kilogram meter per second square. Okay. And this is m raised to power negative 1. And this is so this y I multiplied with kg. Okay. This y I multiplied with m, and this y I multiplied with negative 2, and this y I multiplied with minus 1 as well. So m raised to power negative y and m raised to power positive y cancel out each other. So this will become m, and x, the other one is minus 3z. What about the for second? For second s, it will be minus 2y. There is no other for second. And for kg, we have y here and we have z here. So I can say it is y plus z. Is it clear? Anyone having a doubt or a question till this point?
No, sir.
Okay. Now we just compare. Now we just compare, like example, kilogram does not have any unit, so it means it is 0 here. So when we compare kg with kg, kilogram with kilogram, so it will be 0 is equals to y plus z. If I compare, so m here is 1, so 1 is equals to x minus 3z. And then for about the second, here is minus 1 and here is minus 2y. So again, the minus 1 is equals to minus 2y. So we have 3 equations and we will solve. Like how it can be done. First, from this one, I will get the value for the y. How to get the value of the y? I'll just use the space here. So for this one, we can say minus 1 is equals to minus 2y. So 1 by 2 is y. So value of the y is half. Okay. Then if I use this equation, so 0 is equals to y plus z. So y is equals to half. This will move other side. So z will be equals to negative half. We got the value for z. And what about x? So here, here 1 is equals to x minus 3z. So when we substitute minus 3 and then minus 1 by 2, so this will become 1 is equals to x plus 3 by 2. Move other side. 1 minus 3 by 2 is equals to x. When you simplify this, this will be 2. And this will be 2 minus 3. So value of the x is equals to minus half as well. So x is equals to negative half or minus half. So we got the value of x, we got the value of z, and we got the value for y as well. Now we'll just substitute these values. We'll just substitute this value. This is our main equation. So Young's the speed is equals to k times lambda raised to power x. So what is the value of x? The value of x is half. So this will be 1 by 2. Okay. Then the value of gamma raised to power, like surface tension raised to power y, the value of the y is half, so we put half. And then the density raised to power z, the value of the z is negative half, so we put negative half. Now, so we can say this is equals to k times, the gamma will remain in the numerator, rest both of them will be in denominator, lambda raised to power half, density raised to power half. So it can be written as V is equals to, it can be written as V is equals to k time, power half means root, so root gamma divided by under root lambda and under root rho. So I can write it separately, but they are multiplied, so I can write them together. I can write like this: k lambda raised gamma raised to power, like gamma root square root, lambda in the root, as well as density in a root. But because these two roots are multiplied, so I can write them together. So this is the final relation or the equation between these two quantities. Yeah, it does not matter which variable we put as a power x, y, z, a, b, c. That does not make difference. Is it clear how to work out the equation? Anyone having a doubt or a question related to this topic?